Good morning, students. I welcome you all to second lecture of heat and thermodynamics. Okay, lecture number 2. So in first class, that means basically in first lecture, we had discussed some of the important things about heat and thermodynamics. Basically, we had just moved with the introduction part. And in lecture number 2, we are going to discuss some more new concepts. So before going to approach those concepts, we'll just recall what all the things we had discussed in our previous class. So basically, thermodynamics means what we had discussed. Thermodynamics, it is a branch of science where we are going to discuss about interconversions of mechanical energy to heat energy. And system we had discussed, surrounding we had discussed open system, closed system, isolated system, diathermic wall, and one more we have to discuss, that is nothing but what? Adiabatic wall. Diathermic wall means conducting wall in simple words. Clear? Adiabatic wall means non-conducting wall. What is this? Non-conducting wall. Adiabatic wall means non-conducting wall, or we can call this wall as insulated wall. Insulated wall. Clear? So how to understand what do we know as adiabatic wall? Imagine that here we are having system A, and this side I am having system B, and in between these two, let us assume I am having this adiabatic wall. Clear? This is nothing but what? Adiabatic wall. Adiabatic wall. Adiabatic wall means a wall which doesn't conduct heat from one system to another system. Clear? And no doubt here also, surrounding also, we are having adiabatic wall only. So I am not drawing that part. So let us assume in the similar manner, system A, let us suppose this is having some 95 degrees Celsius, okay, as the temperature, and system B is having, let us suppose this is having some 15 degrees Celsius. So temperature difference is there. That means this is having 95 degrees Celsius, this is having 15 degrees Celsius. This body, this system is measuring temperature of 95 degrees Celsius in degree Celsius scale, and this system B, it is reading 15 degrees Celsius. In between these two systems, system A and system B, we are having which wall? Adiabatic wall. Clear? So now adiabatic wall means that wall is non-conducting wall. Correct? Huh? That means here 95 degrees Celsius we are reading, here 15 degrees Celsius we are reading. Even though temperature difference is there, heat doesn't flow from system A to system B, or this body A to body B. Why? Because in between system A and system B we are having adiabatic wall. So adiabatic wall is a wall, and basically that is nothing but what? Non-conducting wall. Heat doesn't flow from one part to another part. So this is about what do we know as adiabatic wall. So shall I erase the board? Okay. Next thing we should have to understand, what do we know as thermal equilibrium. Thermal equilibrium. In thermal properties of matter, we had came across this point, correct? No? What do we know as thermal equilibrium? So let us assume here I am having one system A which is reading some 80 degrees Celsius, let us assume, and here I am having one more system, let us name this system as B, and this system is having the temperature of 10 degrees Celsius, let us assume. So when we are placing the system A with the system B, that means I am going to combine these two systems. Combine means I am going to join this system A with system B. Clear? At that time what will happen? This side is completely conducting wall. Okay, diathermic wall. Here also diathermic, here also diathermic. So when we are placing the system A with system B, what will happen? Some amount of heat energy will flow from system A to system B. Why? Temperature difference is there. Correct now? Heat is nothing but the form of energy which transfers from one body to another body provided the temperature difference is there. Here 80 degrees Celsius, here 10 degrees Celsius. That's why from body of higher temperature to the body of lower temperature, heat will be transferring. That means the resultant situation will be in this manner. This is nothing but system A, and right side we are having system B. Okay, when we kept like this two systems, then what will happen? Come on. Some amount of heat energy will flow from system A to system B. So now question arises, still how much time this process will continue? Okay, here 80 degrees Celsius was there, here 10 degrees Celsius was there. Alright, here 80 degrees Celsius initially, here 10 degrees Celsius. Now what will happen? From 80 degrees Celsius, some amount of heat energy in this system A, which was at earlier 80 degrees Celsius, that some amount of heat energy will flow to system B. From higher temperature to lower temperature, heat will be flowing. 80 degrees Celsius is higher temperature, 0 degrees Celsius is lower temperature. So based on that, amount of heat energy will flow from system A to system B. Now question arises, till what time this process will continue, correct now? So the process will continue till these two objects will gain same temperature, or these two systems should read same temperature. Till that point the process will continue. Till that point that heat will flow from system A to system B. Let us assume system A now it is reading some 50 degrees Celsius and system B is also reading 50 degrees Celsius. Now these two systems, these two objects are said to be in thermal equilibrium. Yeah. So thermal equilibrium, how to define thermal equilibrium? How we can define this term thermal equilibrium? Two systems are said to be in thermal equilibrium if they have same temperature. If they have same temperature, then we can tell that both the systems are in thermal equilibrium. Clear? And one more thing about thermal equilibrium you should have to remember. Now, just now what we had discussed, thermal equilibrium means same temperature. Correct? Same temperature T. Both the objects should have same temperature. Clear? Now, one more thing you should have to remember in thermodynamics. What is that? Thermal equilibrium means thermodynamical variables should be constant. That means these values should not change. That means thermodynamical variables means what? Pressure, volume, temperature, clear? And entropy, enthalpy, mass of the gas, number of moles, these are all variables only. Quantities will be changing with respect to time. So thermodynamical variables, here TV stands for thermodynamical variables. Don't treat this T as temperature, this V as volume. This thermodynamical variable should not change. That means thermodynamical variable should be constant quantities. Clear? Thermodynamical variable should be constant. These values should be constant. Clear? Now, let us assume an interesting case when we can judge that system is in thermal equilibrium if it is having different temperatures. So I will be erasing this part. Just hold on 1 second. Okay, alright, listen. So here let us assume that I am having one system A, okay, and let us suppose that these walls are completely insulated walls. These walls completely, all four sides, we are having which walls? Insulated walls. Insulated walls means adiabatic walls. Adiabatic walls or non-conducting walls. Okay, and let us assume here I am having one more system. What is the name of this system? System B. Clear? And for this system, again we are having adiabatic walls. Here also we are having completely adiabatic only. This is completely adiabatic. Heat doesn't flow from this system to outside surroundings. Okay. These walls are nothing but what? Adiabatic walls. Clear? Here also adiabatic walls, here also adiabatic walls. Let us assume here temperature we are having 95 degree Celsius. And at this point let us assume that we are having the temperature of some 30 degrees Celsius. Clear? Now if we club these two systems means, listen carefully, system A, system B, I am bringing in contact. Resultant figure will be in this manner. Correct? Huh? Resultant figure will be in this manner. These are all which walls? Adiabatic walls. Getting or not? These walls are adiabatic walls. System A, system B, 95 degrees Celsius earlier, here 30 degree Celsius. Now listen. Now systems are joined together. System A has been joined with system B. Now system A is reading 95 degrees Celsius. At present situation, system B is having 30 degrees Celsius. Now just think about this. In between we are having which wall? In between we are having which wall? Adiabatic wall. Adiabatic means what? Non-conducting wall. Okay, here we are having non-conducting wall. That means, do we have any chance of flow from heat? Heat should flow from A to B, like that. Any condition we are having? Just check. Here we are having temperature difference. Heat should flow from higher temperature to lower temperature. But is it possible? You just think of it. No. Why? Because in between we are having adiabatic wall. So heat doesn't transfer from system A to system B. Clear? Heat will never flow from A to B. Why we are having means, why? The reason behind that means we are having adiabatic walls. Now just think about it. If this adiabatic wall is replaced by diathermic wall means what will happen? Diathermic wall means what? You just think about it. What do you mean by diathermic wall? Diathermic wall means what? Diathermic wall is good conductor wall. Correct? It conducts amount of heat energy. Basically heat will flow from higher temperature to lower temperature. In between we are having diathermic wall means it conducts that amount of heat. But now here we are having adiabatic wall. Now just think about it. Here let us assume for system A pressure is P, volume is V, temperature is T. So to specify for A means I will be writing PA, VA, TA like this. Okay, pressure, volume, temperature. Here PB, VB, TB. Pressure for B, volume for B, temperature for B. Now system A values are pressure, volume, temperature. B is having the pressure, volume, temperature values as PB, VB, TB. So one more definition I had told you. To remember what? Thermal equilibrium. Thermal equilibrium can be attained if system is not changing its variables, thermodynamical variables. Now here you just think of it. If I am talking about only system A means, only this system A means, initially also same condition na, PA, VA, TA, pressure, volume, temperature, PA, VA, TA. So after joining, that means after combining also same values, PA, VA, TA means these PA, VA, TA values are constant values. Clear? PA, VA, TA values are constant means what we can tell, system A is in thermal equilibrium. System A itself alone, it is in thermal equilibrium. System B is also in thermal equilibrium because initially here values are PB, TB, VB. PB, VB, TB. That means if I talk about only system B means, no doubt system B is having again PB, VB, TB, PB, VB, TB means thermodynamical variables are constant here also. That means system A, system B are thermal equilibrium, but provided A thermodynamical variables are constant, B is also thermodynamical variables are constant. If somebody asked you, if two systems are there having different temperatures, can thermal equilibrium be attained or achieved means what you will be telling, yes or no? Thermal equilibrium can be achieved, but provided these thermodynamical variables should be constant and walls should be insulated walls. Then only this condition will be satisfying. So if you understand what is thermal equilibrium means, based on first definition of thermal equilibrium, first definition means which one? Two bodies A and B are said to be in thermal equilibrium. Okay, initial previous definition. If they have same temperature. If that definition if you are knowing means, you can learn the laws of thermodynamics. Basically we are having three laws. First law is like means they had named like that, zeroth law, first law, second law. So zeroth law is based on thermal equilibrium. Just hang a minute, I will just erase the board and again we will be back. Okay, so laws of thermodynamics. So basically zeroth law of thermodynamics, first law of thermodynamics, and one more, second law of thermodynamics. So in this class we'll be discussing about what do we know as zeroth law of thermodynamics. Clear? Zeroth law of thermodynamics. Zeroth law of thermodynamics. Now listen. Initially I had told you zeroth law of thermodynamics is based on what concept? Thermal equilibrium concept. So thermal equilibrium means what? According to first definition, temperature should be what? Constant. Correct? Huh? So temperature should be constant. Listen. Concept of zeroth law of thermodynamics. Concept behind this is nothing but temperature. Concept behind this is nothing but what? Temperature. So they may ask in 1 marks means you should have to write temperature. Directly they will be asking, no worries about that. What is the significance of zeroth law of thermodynamics, or what is the importance of zeroth law of thermodynamics? What is the concept about, what is the concept behind zeroth law of thermodynamics means? Concept is nothing but temperature. It signifies the value of temperature. It gives the importance of temperature. Okay. Now, what this zeroth law of thermodynamics states? Imagine that here I am having one system. Let us name this system as system A. And here I am having adiabatic wall. Listen carefully. This is system A. This is adiabatic wall, and here I am having system B, and these two systems are joined with one more system. This system is C. Now listen, this is adiabatic. This two lines means adiabatic here. Okay, adiabatic wall. Here also adiabatic, 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 adiabatic. Okay, these are all adiabatic walls. Adiabatic walls, non-conducting walls, or insulated walls, whatever you want, you can call them. Okay, adiabatic walls. Now question arises, if these all are adiabatic walls means, what is this wall? Here can you able to see this line? This is nothing but what? Conducting wall. Okay, this is nothing but what? Conducting wall. System A, system B, this is nothing but what? Conducting wall or diathermic wall. Okay, diathermic wall. And these all are what one? This is nothing but what? Adiabatic wall. Okay, are you getting? So system A, system B, in between system A, system B, adiabatic wall is there, and in between A and C, conducting wall, that means diathermic wall. In between B and C, again conducting wall, diathermic wall. Listen, now let temperature of A be TA, temperature of B be TB, temperature of TB, C be TC. Now, if these two systems, that means system A and system B, C, in between them diathermic wall is there, that means after some time these two temperatures will become equal because diathermic wall is there. Listen carefully. Diathermic wall means conducting wall. Conducting wall means among these two, where temperature is high, from that body to where temperature is low, for that body heat will transfer. Now only A and C we are considering, system A, system C. These temperatures later we will talk about. System A, system C. Imagine here we are having maximum temperature, here we are having minimum temperature, means some amount of heat energy will transfer here. If system C is having maximum temperature, system A is having minimum temperature, means heat will flow from C to A. Clear? Now come to this system. This system is nothing but what? System B. Now from B to C we are having which wall? This wall. This is nothing but what? Conducting wall. Here also conducting, this is also conducting only single. Now here also what will happen? Heat conduction will takes place. Okay, that means heat will flow from the body where higher temperature is there to the body where we are having lower temperature. So if C is having maximum temperature, B is having minimum temperature, means C to B heat will flow, or C is having minimum, B is having maximum temperature, means from B to C heat will flow. So this is the process. So after some time what will happen? System A, system B, system C, all these three systems will be having same temperature, because here also heat conduction will take place, here also heat conduction will take place. We know that here heat conduction is not taking place. It is like in your 7th, 8th standard you will be solving some numericals, no? If A is equal to B, B equal to C, means then A equal to C, like that. If temperature A equal to temperature B, then temperature B equal to temperature C. All the three temperatures will be same. So now which condition is achieved? Thermal equilibrium condition is achieved. What is the first definition of thermal equilibrium? Thermal equilibrium is nothing but what? Two or more objects are said to be in thermal equilibrium if they have same amount of temperature. Now here what is going on? All the three systems are getting That means all the three systems are achieving same temperature. That's why we are telling system A is in thermal equilibrium with system B, and system B is also in thermal equilibrium with system C. Basically what I am trying to tell means system A, system B, system C, all the three systems are in thermal equilibrium. Clear? So this is about zeroth law of thermodynamics. Okay, important from examination point of view. They will be asking number of times they had asked already. They may ask this year also, but you should have to be prepared with definition about that as well as explanation how you are going to explain this. Okay, so zeroth law of thermodynamics is nothing but what? If two systems A and B are separately in thermal equilibrium with one more system C, then system A as well as system B are in thermal equilibrium. This is the statement about zeroth law of thermodynamics. So what is the statement of zeroth law of thermodynamics? If system A and system B, if two systems, system A and system B, are separately in thermal equilibrium with one more system C. Why I am using the word separately in thermal equilibrium with one more system C means A is in thermal equilibrium with C, but A is not directly in contact with B, but B is in contact with C. System A is in thermal equilibrium with C, this part. System B is also in thermal equilibrium with C, this part. That's why two systems A and B are separately in thermal equilibrium with one more system C, then system A as well as system B are said to be in thermal equilibrium. This is the statement about zeroth law of thermodynamics. Clear? So what all the things you came to know today? So today we had discussed what is insulated wall, correct? No? Basically non-conducting wall or adiabatic wall. Next, what is thermal equilibrium? So thermal equilibrium means what? Thermal equilibrium is nothing but if two objects are said to be in thermal equilibrium if they attain same temperature. Clear? And next, one more definition about thermal equilibrium is nothing but what? One more definition about thermal equilibrium. Will you try? Thermal equilibrium is nothing but the condition where pressure, volume, temperature, basically thermodynamical variable values will remain constant. Those values doesn't change. Clear? And next after that we had discussed laws of thermodynamics. In that basically just first law we had discussed in this class. Basically first law is nothing but what? We are treating it as zeroth law of thermodynamics. Don't get confusion. Zeroth law of thermodynamics. Next, zeroth law of thermodynamics states that if two systems A and system B are separately in thermal equilibrium with one more system C, then system A and system B are also said to be in thermal equilibrium. These sides are completely adiabatic walls. Don't worry. Clear? And in next class we will be discussing with very important factor, that is nothing but internal energy. So be prepared with this much concept, because internal energy, okay, and amount of work done, how to calculate work done values, derivations also will be going ahead, and some processes we are having, very easy processes like isothermal process, okay, and adiabatic process. So like this we are having totally 6 processes. Each processes will be discussing very detailedly, and for isothermal and adiabatic processes work done derivation is important. For next coming processes like isochoric process and isobaric process, there are those two derivations are very easy derivations, but from examination point of view in 2020 Work done in case of isothermal process they had asked, but this year which one they will be asking we don't know. Again we will be meeting in our next class. So till that time, please don't waste your time. Read well, okay? Make the notes completely right and practice notes and everything. And as usual, if you are having any doubts, means how you will be referring these many days, in the same manner you have to proceed. Note down in separate notebook, and when college reopens, you can come and ask those doubts freely. Okay? So keep studying, don't waste your time. Thank you.